sometimes when working with numbers, we want to like access like something like pi, or figure out like what the maximum value of like a number could possibly be, or get the power to like to something else. And in most other languages that I've worked with, there's a centralized math library that's part of like the standard library that you can just pull in and do a bunch of those operations on. However, we can't really find that in Rust because there is no centralized math library. Now, there are math crates that you can pull in, but that seems like it's a bit much if we just want to like get, something to the power of like 4, let's say. So let's figure out how we can actually do that. And there's 2 different ways to get information about numbers in Rust. So let's say we have something like a number. Let's do like an I32, let's say. So let's do my number equals, I don't know, let's say 10. By default, numbers are I32s just when we create them, unless I give like a dot, then it'll be a default of an F64. Now, if I want to take this number and raise it to the power of, I don't know, something, let's see, let's do like larger number is going to be equal to number. Well, I can actually just call methods on this primitive type, even though it is a primitive type. So dot, and here we can see all of the options that we have. I can get the absolute value of it. Well, it's an I32, so it could be negative. I can get, let's see, there's a lot of these things. Is negative, is positive, just Booleans. There's a lot of methods here that we can use. Let's find here, pow. So I can do dot pow to 2. So raise number to the power of 2. And let's go ahead and debug this larger number and see what we get out of this. Oh, that's not happy with me. Need to make this a little bit smaller so I can read it. Can't call pow on ambiguous type. Oh, ambiguous number type. So even though it sees that like, hey, this is an I32 here, the compiler itself is like, well, I think that it's going to be an I32, but because you're calling pow, we can have power on like I32s, U32s, F32s, I16s, I8s, like all of those can have pow on it. So which one do you really want? So let's go ahead and set this to be an I32 explicitly, and now it's going to be happy. Let's try this again. I run you. Now we see that we got our large number is 100. So that's 10 to the power of 2. Now that I've given it a very explicit type, let's see what other things that we can have here. So pow, like there's a whole bunch of these that are like really kind of strange. Let's do an F32 because those can be a little bit interesting when we get powers to that. So number dot pow, and we have pow F and pow I. Well, pow F allows me to raise something to a floating point power. So pow F, and now I can give this to be like, well, I want like 2.5. So 10.0 to the 2.5. So it's not something I've ever needed done on my code. Usually I just do pow I, but it is something that we can do if you really want to do that. So where do we go find what these methods are? If you go to the standard library, you can search for whatever number primitive type you want. So here I am on I32. So the way I found this was I just came here, typed I32, just clicked on this. And here's all these methods that you can use along with the documentation for how to use it. Now, if I want to find pi, let's say, well, finding pi in an I32 is probably not going to be that helpful because, well, I mean, that would just be 3, right? So let's go find pi here. And we'll see that there's actually several of them that we can choose from. So there's not just like one math library that gives me pi, and then I can restrict it to like an F32 or an F64. It looks like we have pi only on F32 and X64, but they're constants here. So if I come here, we can see it's a const pi off of F32, and then this is what it's set to. And it looks like it's just hard coded in. So if I want to grab that out here, what that would look like is pi equals F32, so just this the type itself, colon, because we're doing the equivalent of getting a static like function on it. And then I think it's, what is it, pi? Is it like that? No, you're not happy. Let's see, where are you? You're F32 pi. Oh, it's F32 const. I missed that. I don't see that as working either. Okay, what do we need to do? Oh, standard F32. There we go. If I save this, so standard library, F32, constants, pi. I mean, it's a little bit of a mouthful to sort of like to get, but this is where to find things like this. Now, if I don't put that in there and I just do my double colons, I can now see all of these things that I want. So let's say I want half of pi. Well, there's a bunch of these here. Frac, frac 2 of pi, or the square root of 2. There's logs that we can grab out of here too. I generally don't use these very often because, like other math libraries, when I'm having things like move around, I often just use vectors and vector math. But if you ever working with circles and you need to like figure out exactly where on a circle something is, pi, like this, you're going to be grabbing into pi quite often. So if we just go to pi again, here we are, our F32. If I wanted the F64 version to be more precise, we just replace this with the X64, and there we are. Let's go ahead and debug out pi. And here he is. Here is the F64 version of pi. Hopefully this is really helpful, and you can just call these things sometimes when we're just using a good tool like VS Code, or if you're using Vim with like a Rust analyzer installed, you can just type your number, hit dot or double colon, and then just should see all the things you can possibly run on it. Or you can just go to that documentation and play around there. Hopefully this is helpful, and I'll see you in the next video. Bye.